Mr. Sarles here. Lesson 5.3, Confidence Intervals. A little review to start. What did the 68 represent in the 68, 95, 99.7 rule of thumb? Pause the video, take a guess, then play. Okay, in any normal distribution, 68% of the data is within one standard deviation of the mean. Mean is in the middle of the graph, one standard deviation each way. The green section represents 68% of the entire data. Now, we're going to do a variation of that. I want you to figure out how many standard deviations do you need to go out to capture 80% of the data. Formally, it's written as, on a standard normal distribution, find z such that 80% of the data is between z and negative z. But it actually means exactly what I just said. How far do I need to go out from the mean to capture 80% of the data? Okay, well, I'm given a percent, and I need to work backwards to figure out what this place is, what this mark is, called z. Well, to do that, I'm going to do an inverse normal calculation, but I need to know the percentile for z. Percentile is everything below that value. Well, here I have 80%. What's in this tail over here? Pause. See if you can figure that out looking at the graph. Here's one way that students will often do it. 80% symmetric, so it means I have 20% left, meaning each of these tails have to hold 10%. So now I know the percentile for z, 90%. Now I can do the calculation. Inverse normal, 90%, 0, 1. Why 0 and 1? The standard normal curve always has a mean of 0 and a standard deviation of 1. Look at the last thing from yesterday's notes to review that. Calculating that, you get 1.28. What does that tell you? 80% of the data is within 1.28 standard deviations of the mean. All right, kind of a cool shortcut to actually figure out the percentile. The percentile again was 90%. Take a look at this once. I have another version of the same graph. This one I have 100% of the data shaded in. I'm going to take this little tail over here. Let's flip it. And I'm going to use that to fill in the answer up there. Well, now I actually have exactly what I wanted, but I actually have two versions of it, 100%, 80%. 100 plus 80%, since I have two copies, I only want one of them. The correct answer is 1.8 divided by 2, which is the 90% or 0.9 that we got last time. So shortcut, whatever your percent is, add 100% to it, divide by 2. Okay, see if you can figure out how many standard deviations do I need to go out to capture 95% of the data. Pause the video, try working it out, come back. I did the shortcut. 100% plus 95% divided by 2. 1.95 divided by 2. I can actually type that into the calculator. I got 1.9599. So 95% of the data is within 1.96 standard deviations of the mean. Notice 95% was our rule of thumb number, and notice it really is close to 2 standard deviations. This is the exact answer. Our 2 was an approximation using a rule of thumb. Okay, we want to predict the average height for all Eden Prairie High School students. So I have each one of my FST students pick 5 kids from the school randomly. They measure the heights and then find the average of those 5 heights. The graph of the result is shown below. Pause for a second. What does the red dot in the graph represent? The red dot. One of my students randomly picked 5 kids, found their heights, found the average. That 69 right there was the average that they got from those 5 kids. So each of these dots was gotten in the similar manner from a sample size of 5 kids. So what do you think the average height of all Eden Prairie High School students is? Well, based on the graph, I would predict the middle, which appears to me about 67 inches. Okay, this time I have my students go out and randomly pick 20 kids from the school, measure the height, and then find the average of the 20 heights. For a second here, pause the video. What does that red dot above the 68 represent? Pause and come back. That 68 was obtained by one of my students measuring the heights of 20 kids, taking the average, and then graphing it. So that one red dot is the average from their 20 kids. Each of the other dots was gotten in the same way. What do you think the average height is based on this example? Again, I would predict it's about 67 inches, approximately the middle of that dot plot. Sample size of 5, sample size of 20. Compare the two graphs. What do you notice? Both distributions are unimodal, approximately one peak. If I made a smooth curve going over the top of these, it looks like it has one peak. So unimodal, one mode. Symmetric, left tail and right tail are about the same shape. And both appear to have a mean of approximately 67. With my larger sample size, it appears I have less variability. So I said standard deviation. So the standard deviation of the distribution when n equals 20 is less than the standard deviation when n is 5. Okay, again we want to find the mean height of all Eden Prairie High School students. Give me 2 values that you are pretty sure that the mean is in between. When students do this in class, they typically will look at this right-hand graph because it has less variability, and they'll look right about here and right about here, and they say, I'm pretty sure that the true mean is somewhere in there. So I'm fairly confident that the mean height of all students is somewhere between 65 and 69 inches. Okay, some terminology. Point estimate. If you were going to make one predicted answer, what would it be? In our problem, we predicted 67. 67 is our best guess at a point estimate. Okay, confidence interval. Confidence interval is a range of values. So it uses the point estimate and something we'll talk about next called a margin of error to build a range of values that you are confident captures the true mean. In the problem we just had done, it was 65 to 69 was the confidence interval we built. Now, our point estimate is right about here, and the ends of our interval were 65 and 69. The distance between that point estimate and one of our ends is called the margin of error. So in our problem, it is 2. 65 to 67 has a length of 2. 67 to 69 has a length of 2. Okay, from previous studies, we know the standard deviation of heights of all high school teenagers is 3 inches. Now, we took a random sample of 25 Eden Prairie High School students and found the sample average of those 25 students to be 67 inches. We're going to use a more sophisticated formula to build a confidence interval. We're going to do it at a 95% level. Okay, take a look at the formula. X bar is given 67 inches. The standard deviation is also given. It is 3. The 25, that is the n in the problem, so all we have to do is figure out this z star. Well, the z-star in the problem just represents the number of standard deviations we need to be 95% confident. This happens to be exactly what we did at the beginning of the lesson today. So, 95% confident, how many standard deviations do I need to move over? In this case, it ended up being 1.9599. Okay, plugging everything in. 67, 1.96. 3, square root of 25. Square root of 25 is 5. 3 divided by 5 is 0.6. 1.96 times 0.6 is 1.176. Okay, tying in the last slide to this slide. 67 is our best guess. That's what we got in our sample. So that's our point estimate. This amount that we are going above and below is called the margin of error. So we go positive or negative 1.176. Subtracting that amount and adding that amount, I get this range of values. That is our confidence interval. Let's quickly use our calculator to verify the answer. So, get to the main screen, go to Stat. Now I'm going to go over to the column that says Tests. The one we're using here is something called the z-interval. Remember the z-star we had in our problem? That is going to remind us to use the z-interval. We have stats and data. Here in this problem, they gave us the stats. The standard deviation was 3. X bar was 67. The size of our sample was 25. Our confidence level was 0.95. 95%. You must type it in as a decimal or it'll give you an error message. Hit calculate and notice you get exactly the answer we got by doing it by hand. So a good way to check your answer quickly. Okay, last slide. Interpret what this confidence interval means in context. So we are 95% confident that the true mean height for all Eden Prairie High School students is between 65.82 and 68.18. This slide here exhibits the importance of statistics. We were able to take a sample of 25 Eden Prairie High School students and make a prediction for all Eden Prairie High School students. That is one of the main purposes of statistics. All right, thank you guys for listening. That is the end of lesson 5.3. In fact, that is the end of chapter 5, part A. Monday next week, you guys have off for Memorial Day. Enjoy it. Tuesday and Wednesday, we'll be reviewing for the test. The test will be next Thursday.